Good afternoon, grade 8s, and welcome back to another episode with Masculine Learning and Masky TV. Today's focus point is on the Theorem of Pythagoras. All right, a new concept, a new topic. Let's get into it. All right, so before we start any topic, we need to get familiar with our objectives. And in this lesson, the first objective is for us to define what this theorem actually is. And then we need to identify the sides in a right-angled triangle. Emphasis on right-angled. And then we need to apply the theorem of Pythagoras to solve unknown sides in a triangle. And then lastly, we need to verify whether a triangle is indeed a right-angle triangle or not. Okay, so what does this theorem actually say? If we look at the theorem of Pythagoras, right? I want to ask a question. What is the root word of theorem? It's theory, all right? So in other words, we are talking about the theory, and the theory is usually something that has been proven. So what has been proven in relation to Pythagoras? It has been proven that in any right-angled triangle, so I'm going to underline right-angled. What does it mean when a triangle is a right-angled triangle? It means it has one angle that is equal to 90 degrees. So if I take my protractor and I measure the exact size of this angle over here, I will come to see that the angle is indeed 90 degrees. So a triangle which has an angle of 90 degrees is called a right-angle triangle. All right. So in a right-angle triangle, the square on the hypotenuse. Now what is the hypotenuse? The hypotenuse is the side opposite the 90-degree angle. So if I draw a triangle, and I can name this triangle, ABC. Here I have my angle that's equal to 90 degrees. So we know a triangle has three sides, and a triangle has three angles. So here's my first side, AB. Here's my second side, BC. And here's my third side, AC. So the side that is directly opposite the right angle triangle, which is the side AC, that is what I call the hypotenuse. All right? So in a right angle triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. Now that's quite a mouthful, but let's see how simple it actually is. So this is what the theorem of Pythagoras is telling us. It is telling us that if I take the hypotenuse, which is my side opposite 90 degrees, and I square it, multiplying it by itself, that is then equal to, look what it says, the sum of the squares on the other two sides. So it is the sum of the squares, squaring, on the other two sides. So obviously, if I have a hypotenuse that is one side that's taken away from my three sides, I'm left with two more sides. So his theorem is telling us that when I square, by the way, Pythagoras is a man that has invented this theorem. You can look him up if you have time. So if you square this hypotenuse, it will be equal to the one side squared plus the other side squared. That's all his theorem is saying. And just look what it looks like as an example, right? So here I have a triangle. There's my right angle in the corner. So opposite my right angle, I have a side. So if whatever side this is, squared will be equal to this squared plus that squared. So they're telling me here that the length of this side is what? 5. That's the long side, the hypotenuse. They're telling me the length of the one short side is 4. They're telling me that the length of the other short side is what? 3. So if I squared 5, 5 squared is not 5 times 2. 5 squared is 5 times 5, which is what? 25. So if I square 5, I get 25. So I have 25 blocks over there. So I know that this long side, if I square it, it should be equal to the sum of the squares on the other two sides. So if I take the one short side, which is 3, and I square it, what do I get? I get 9. There's my 9 blocks. And then if I take the other short side, which is 4, what do I get? 16. So because 4 times 4, 4 squared is what? 16. And if I add 9 and 16, what do I get? 25. So again, all this theorem is telling us is that when I square the hypotenuse, it must be equal to the sum of the squares on the other two sides. All right? Now, that's the first part. That is what Pythagoras' theorem says. Now, they can also ask a question whether a triangle is a right angle triangle or not. Because remember, sometimes students tend to solve an unknown side using Pythagoras, but it's important to check whether your triangle is right angle triangle. Most of the time, they give the angle to be 90. Other times, they do not. So here we have a scenario. And this scenario is asking us to check whether this triangle, which is PQR, is a right angle triangle, if it has one angle equal to 90 degrees. So what do we do to answer that question? We must check whether the square of the longer side is equal to the sum of the squares of the two other sides, or the two shorter sides. So I first look at this triangle, and I need to establish what is the longer side. So it's very obvious that between 6 centimeters, 12 centimeters, and 15 centimeters, the longer side is 15 centimeters. So I first squared 15 centimeters. What do I get? I get 225. Right? That should be centimeters there, by the way. Okay, let me put this on. So I get 225 centimeters. Now, what's my next step? I need to square the other two sides, the two shorter sides, and then see whether I get 225 if I add them together. So if I square the one short side, which is 12, so 12 squared is 144, plus the other short side is 6. If I square 6, I get 36, and 144 plus 36 is 180. Now obviously, 180 is not the same as 225. So I'm making a conclusion here by saying, so 15 squared, which is the longer side, squared, is not equal to the sum of the two shorter sides squared. It is not equal to. Therefore, the triangle is not a right angle triangle. That, boys and girls, is how we check whether a triangle is right angled or not. Okay, now we have a bit of an activity to do over here. And it says determine whether the triangle is a right angle triangle or not. So here, so we can see we have 3 triangles. And most of you by inspection would probably say that is a right angle triangle because you can take a protractor and you can measure the size of the angle. But we're going to use its sides to determine whether the triangle is 90 or not. So let's see. We give it the angle ABC, PQR, RST. So here's my short sides, the sum of the squares, and the hypotenuse. So obviously, we're talking about the angle ABC only. So AC, so where's my side AC? Here it is. Remember, I have 3 sides in my triangle. If I square it, if I square AC, 4 squared is what? 16. So here I have 16. All right? BC squared, so the side BC is 3 units. If I square it, 3 times 3, not 3 times 2, 3 times 3, remember? So 3 squared is not equal to 3 times 2. That's a very big misconception among students. 3 squared is telling me that I'm squaring this number, right? I'm repeating this number. So it's 3 multiplied by 3, which is obviously 9. So here I have 9 units. Then I'm going to square the 2 short sides. So 9 plus 16 is 25. So AC squared plus BC squared is 25. Look what they're asking me to do. They're now asking me to square the hypotenuse. The hypotenuse, right, is what? 5. So 5 squared is what? 25. So what do I notice? They're asking me here. So I did the first row for you. And I'm going to go to my next slide quickly where the solutions are in. So I don't have to repeat the step. All I did was I looked at my triangle and then I just squared and I added in the end. So what do we notice here? It's saying compare the values in the last 2 columns. What do you find? So I find that when I square the two shorter sides in all three triangles, so you can see in triangle PQR as well, if I square PR, if I square QR, I get 100. But then the longer side squared is also 100, right? If I in triangle STR or RST or TRS, if I square the two shorter sides, I get 169 units, but that is indeed the length of the long side as well. So my conclusion is right, so to answer, so I've completed 2.1 in my table. Now I will do 2.2. Write down, compare the values in the last two columns. What do you find? Right, I found that the sum of the two short sides squared is equal to the long side squared. So if I square the two short sides, it is equal to the long side squared. And that's exactly what I said in terms of proving whether a triangle is indeed a right angle triangle. And we have now just proven that triangle ABC, triangle PQR, and triangle RST are indeed right angle triangles. Okay? So now, let's answer the last question quickly. In a right angle triangle, the sum of the squares on the two shorter sides is equal to the square on the hypotenuse, of course. So the hypotenuse squared is equal to the sum of the squares of the two shorter sides, and that is where I have my hypotenuse. All right. So on the board, you can see that we have a question that is asking us to calculate the length of the missing side. So we need to calculate the value of A. But A is obviously the side BC. And then in the next question, they're asking us to calculate the length of FD, which is the unknown E. I'm going to leave the slide over here. I'm going to cut for a short break, and I will see you thereafter. Please have a look at it. All right, grades, welcome back. We are still busy with the theorem of Pythagoras. And remember, his theorem says the following. In any right angle triangle, the square on the hypotenuse is equal to the sum of the square on the other two sides. All right. Now it's asking us to calculate the missing sides of the right angle triangle. So I first need to establish that triangle ABC is indeed a right angle triangle. And it's obvious because my angle A is 90 degrees. So just a tip, or important to understand at least, if we have a right angle triangle with two sides given to us, then we need to find the third side using Pythagoras. I will repeat that. In any right angle triangle, when we are given two sides and we need to find a third side, we use the theorem of Pythagoras to do that. Okay? So I'm going to go ahead and I'm going to solve the first problem. I'm going to solve for A. Now the first thing that you do is step number one, you need to set up an equation, right? So we know an equation is an expression with an equal to sign in it. And I set up my equation according to the theorem of Pythagoras. right? What does his theorem say? His theorem tells us, take the hypotenuse and square it, and make it equal to the sum of the two shorter sides squared. So I'm going to take the one short side, which is 4, and I'm going to square that, plus I'm going to take the other short side, which is 3, and I'm going to square it. There we go. There's my equation, right? And my equation has been set up according to the theorem of Pythagoras. Now, very important, you need to remember in geometry, for every statement you must have a reason. So for your reason, you can just say you are using the theorem of Pythagoras. So here I can just say Pythagoras. There we go. So now I'll go ahead and I'll solve for A. So A squared is equal to 4 squared, 4 times 4 is 16, plus 3 squared, 3 times 3 is 9. So now I need to simplify. So now A squared will be equal to 16 plus 9 is 25. Now remember, how do I get rid of any square? Square root, right? So what I do on the left, I do on the right. So I square root A squared, and I square root 25, and A will therefore give me, what is the square root of 25? Which number multiplied by itself twice, give me 25? It is 5. They're not telling me what it is, whether it's centimeters or meters or whatever it is, so I put units. Let me just make this 5 a bit neater. So I will say 5 units. And there I have solved for the one unknown, which is A, right? Now, the next one is E. Now, I want you to spot the difference between these two triangles over here. And the difference is that here, the hypotenuse is what we need to find. And here, the hypotenuse is given to us. We're going to apply the same rule. There will just be one minor change in terms of how we solve it. So the same thing, what did I say? What do we do in order to solve the problem? We set up an equation according to the theorem of Pythagoras. So his theorem tells us, take the hypotenuse and you square it. Right? So I'm going to square the hypotenuse and make it equal to the sum of the two shorter sides squared. So the one short side is E, so I'm going to square that, plus the other short side is what? 12. And I'm going to square that. And remember, very important, after my statement, I put my reason. My reason is Pythagoras. There we go. Now I'll go ahead and I'll solve. So, what is 15 squared? 15 times 15 is 225 is equal to E squared plus 12 squared is 12 times 12, and 12 times 12 is 144. Now you need to be careful. Remember, I want to get the value of E only. So what's in the way on this side? It's the 144. So if I can get rid of this 144, then my problem is solved. And can I get rid of it? Of course I can. What can I do? I can just subtract 144. Isn't it so? I can subtract 144. So I'm going to subtract 144, right, on the left-hand side, and I'm also going to subtract 144 on the right-hand side. And after I have subtracted, then I am just left with E squared, which is what I'm looking for, right? So 225 minus 144 gives me what? 81. Okay? I'm almost done. I need E, but I have E squared. And to get E on its own, I just square root. And I square root. And obviously, once I square root E squared, I'm just left with E. The square root of 81 is what? 9. But I give my answer in units. And that, boys, is how I solve for an unknown side in a right angle triangle if two sides are given. So since we are in the momentum, let's get into it, right? These are my solutions, right? And this I've extracted from page 178 in my Platinum Maths textbook. You go ahead, try it on your own. If you are struggling, you come back to the video and you can watch the solutions. All right, so now I have a little activity for us to go through together. And this activity here, it's in the form of a word problem. But luckily for us, they are giving us the picture attached to it. There can be situations where they do not give us the picture, and we need to use the words over here to draw the picture to give us a visual sense of what it is that we need to find. But because they're giving us the picture over here, it is quite simple for us to actually just solve the problem. So it's telling us here that the ladder stands against a perpendicular wall. So perpendicular means that the angle formed between the two lines makes 90 degrees and reaches a window above the ground. If the ladder is 5 meters long and the foot of the ladder is 4 meters away from the foot of the wall, how high above the ground is the window? So they're asking us to find the height over here. How high is the ground above the window? So they're just asking us to solve for A over here. We need to find the value of A. And that's very simple because we know that all I need to do is I just need to set up an equation using the theorem of Pythagoras. And this theorem tells us that for number 1, what do? I take the hypotenuse, which is 5, and I square it, right? So I'm going to say 5 squared, and that will be equal to the sum of the two shorter sides squared. So my one short side is A squared plus my other short side is 4 squared. And my reason there is Pythagoras. Right? So now I need to simplify. 5 squared, 5 times 5 is 25. Here I have A squared plus 4 squared is what? 16. Isn't it? Yes. So now I need A squared on its own. I want to isolate the variable, get the variable on its own. We know this because we've done it in equations when we needed to solve for x. So I will subtract 16 on both sides. If I subtract 16 on this side, I'm left with A squared. 25 minus 16 is 9. And to get A on its own, I need to square root the right-hand side. I need to square root the left-hand side. So A will give me 3 units. There we go. Not units. Oh, they give us the units. It's meters. So I actually need to put my answer in meters over here. So my answer is 3 meters. All right, that was quite simple. Let us look at the second one, number 2. Again, we have a scenario where we have a rope that is 15 meters long. All right, and we have the rope that is tied to the ground at the point which is 12 meters from the base of the balloon. We need to find out how high above the ground is the balloon, right? So they're asking us again for the height over here, all right? So what I see is that I have a right angle triangle. I have 2 sides given. I need to find a third side so I can apply the theorem of Pythagoras over here. I want you to get familiar with this. Whenever I see a right angle triangle, I have 2 sides given to me, I can apply the theorem of Pythagoras. So they're not giving us any variable over here. And because we're finding the height, we can call it h, right? We can call it h. So, but before that, I know that I must first take my hypotenuse, the side opposite 90 degrees, which is 15. So I'm going to take 15 and I'm going to square it, and that I will make equal to the one short side. I'm going to call it the height. So it is h squared plus the other shorter side, which is 12 squared. My reason there is Pythagoras. You must put your reason down. So 15 squared gives me 225. So here I have h squared plus 12 squared. 12 times 12 is 144. Okay, I will subtract 144 on both sides of the equation, which will leave me with h squared on the right hand side. If I subtract 144 from 225, that should give me an answer of 81. And if I square root both sides, my height will then be, the square root of 81 is 9. So my answer is 9 meters. Okay? And this exercise I've extracted from exercise 17.2, page 230 in my classroom mathematics textbook. And now we're leaving the best for last, one more activity, right, which I got from my Platinum Maths book, right? My Platinum Maths book. This was on page 181, and it formed part of the revision exercise, okay? So, the first question is asking us to complete the statement, and it says, in a what angle triangle, the what on the what is equal to the what of the what on the other two sides. Now we know the theorem of Pythagoras. We're dealing with it now in 4 different problems. So it's very easy for us to complete the statement, okay? So let us do that. So I'm going to say in a what angled triangle? In a right-angled triangle. In a right-angled triangle, comma, the square on the hypotenuse, so I'm going to go the square on the hypotenuse we know that's the side opposite 90 is equal to the sum, I'm going to underline that, the sum of the squares I'm going to underline squares, right, of the other two sides. All right. Now we have something different looking over here, but don't panic, boys and girls. This is just a combination of two triangles that is together. What they can do is they can separate this triangle from this triangle, and we have two separate triangles, but we still apply the same logic to solve for the unknowns. All right. So let's see what they're asking for the last few minutes that we have left. Okay. So we can see over here we have two triangles. In fact, we have three triangles. But we're not worrying about that now. We have AB to be 20 units. We have the side AC to be 15 units. We have AD to be 12 units. And then we know that AD is perpendicular to BC. What does that mean? It means that the angle formed, right, between the two lines that are perpendicular is 90 degrees, right? The first question is asking us, calculate giving reasons, right? I emphasize this. The value of x. The first thing I must do is I need to identify in which triangle is x, right? X is obviously in this triangle over here. So it's got nothing to do with that triangle. Then I check, is this triangle 90 degrees? Yes, it is. Are two sides given to me? Yes, it is. Can I find the third side? Of course I can. So let's go ahead and solve the problem. The theorem tells me, so I'm going to give you a word of advice. If I'm dealing with more than one triangle, stipulate which triangle you are working in. So I'm going to say that in triangle ABD. So in triangle ABD, what do I notice? What do I know rather? I know that the square on the hypotenuse, so 20 squared, is equal to the one short side, which is x, so it's x squared, plus the other short side, which is what? 12. So it's 12 squared. My reason there is Pythagoras. Let us now simplify. 20 squared, 20 times 20 is 400. So here I have 400 is equal to x squared plus 12 squared. 12 times 12, it is 144. We need to know our perfect square as well. To get x squared on its own, I will subtract 144 from both sides. So if I subtract 144 from this side, I'm left with x squared only. If I subtract 144 from 400, I'll be left with 256. Okay, so here I have 256. How do I get x on its own? How do I get x on its own? I need to square root the left-hand side, and I need to square root the right-hand side. Or square root the right-hand side, and I square root the left-hand side. And once I square root x squared, I'm left with x. And then the square root of 256 should give me 16. Are they giving me measurements? No, they're not. So I give my answer as units. Okay? And then lastly, we need to calculate the value of y. Now y, right? So I checked my time. It is actually 5:30, meaning our time is up. But I want you to have a look at how we can calculate the value for y, right? I first have to check, is this triangle right angle triangle here? Most of you will say, no, it isn't. Guess what it actually is? Why is that? Because they're telling us here that AD is perpendicular to what? To BC, meaning that this angle here must be 90 degrees. Alternatively, I know that the sum of the angles on a straight line adjacent supplementary angles adds up to 180. So if I have 90 here, that angle there must then be 90 degrees. So once I have this to be 90 degrees, I have two sides that are known to me, and I can find a third side. You can apply Pythagoras theorem to solve the value of y. Right, girls and boys, I hope that you have enjoyed the lesson. I hope that you have taken note of how we can solve for unknown sides using Pythagoras' theorem. I hope that you saw how we prove that the triangle is 90 degrees or whether it isn't 90 degrees. If you have any questions, do not forget to ask Maskey on the number 072 091 0388. Don't forget to comment, like, subscribe, and I will see you in the next lesson. Goodbye.
And now we enter our next exciting chapter with the launch of Maskeyverse, an inspiring trio of innovations, our AI-powered learning companion, captivating TV content, and a vibrant playground for interactive learning, and our own dedicated app, all coming together beautifully to deliver learning outcomes through technology.